Hi everyone, this is a video just going through some GCSE exam questions. It's the type of mole calculation where you're asked to work out what the balanced equation should be through doing some calculations. So we've got an example question here. It says we've got potassium nitrate. It decomposes on heating to give potassium nitrite and oxygen. And they've given us the masses of some of these chemicals and they want us to write a balanced equation. And they've given us the relative atomic masses as well. So the first thing that I'm going to do is write out an unbalanced equation. So it's saying that KNO3 decomposes on heating, so it's not reacting with anything, decomposes to give KNO2 and O2. Now, you could probably balance this equation now. Just we know how to balance equations, but we need to go through the process of showing that we know how to calculate it. Okay, so the next thing that I'm going to do is just use the information from the question. So it says 4.04 grams of the KNO3. So I'm going to write that underneath here. 4.04 grams there. And 3.40 grams here. So that's all the information in the question. So now you can see I need to work out the missing mass from here. Okay, so that's what we're going to do. So we know that from the law of conservation of mass, that the total mass of the products must be equal to the mass of the reactants. Okay, so what I'm going to do is I'm just going to do this at the side over here. I'm just going to do 4.04 grams minus 3.40. And I'm going to work that out. I'll just do it on the calculator because it's quicker. And we get 0.64 grams. Okay, so that must be the missing mass of the oxygen. Okay, so I'm going to go and put that in here as well. Okay, so now we've got the mass of every chemical. What I now want to do is work out the relative formula mass of each of these. Okay, so to work out the potassium nitrate, we're going to add up all the atomic masses that are in it. So we can see that potassium is 39, so I'm going to do 39 plus nitrogen, which is 14, plus oxygen is 16, but I need to times that by 3. So I'm going to do plus 16 times 3. And that comes out to 101. Okay, so we're going to say here, this is 101 grams per mole. Okay, let's do the same thing for the KNO2. So it's going to be 39 plus 14 plus 16 times 2. We get 85 for that one. And then the O2 is just going to be 2 lots of 16. So that's going to be 32. Okay, so now we have the masses for all three chemicals and we have the relative formula mass for all three chemicals. To work out the balanced equation, we want to know the moles. So to get moles, what we're going to do is do the mass divided by the relative formula mass. Okay. So I'm going to divide this, I'm going to divide that, and I'm going to divide that. Okay. So let's work these out. 4.04 divided by 101, 0.04. So that is the number of moles. Let's do the same thing here. 3.40 divided by 85. That's 0.04 as well. And then this one, 0.64 divided by 32 is 0.02. Okay, so I've got my number of moles, but I'm not going to go and put this in the equation, right? We're not going to have decimals. We want it to be whole numbers. So to simplify this ratio to get it to whole numbers, we're going to divide by the smallest number. Okay, out of these three numbers, the smallest one is 0.02. Okay, so I'm going to divide all of them by that. So here I'm going to do 0.04 divided by 0.02. So that's going to come out as 2, isn't it? This is going to be the same. And 0.02 divided by itself is going to be 1. So that gives me a ratio of 2 to 2 to 1. And so those are the numbers that I'm going to put in the equation to balance it. Okay, so I'm going to write my equation out again, and I'm going to say I've got 2 KNO3, 2 KNO2, and just 1 O2. Okay. That should be a balanced equation. Let's just check it, make sure we haven't messed up somewhere. So I've got 2 potassiums and 2 potassiums, 2 nitrogens and 2 nitrogens, and I've got 2, so I've got 6 oxygens here, 2 times 3, and I've got 2 times 2 is 4 plus those 2, so I've got 6 there. So that is the balanced equation. So that is the answer that we were looking for. Okay, let's just do one more example. Okay, we've got a different question here. So here we've got iron 3 oxide, and it's reduced by carbon to give iron metal and carbon dioxide. So again, I'm going to write out the equation not balanced. So it's Fe2O3 is reduced by carbon, so carbon's just C, and it's going to give iron metal and carbon dioxide. Okay, and they've given us numbers in the question, so let's use those. So we've got 480 grams here. We've got 336 grams of iron and 198 grams of carbon dioxide. So the first thing we need to do is work out the missing mass of the carbon. And again, we're going to use the law of conservation of mass here. So the products should equal the reactants. So if I do 336 plus 198, so that gives me the total on this side is 534. So this side is going to have to add up to 534. So if I do that, take away 480, that gives me 54 grams for the carbon. Okay, now we need to do the relative formula masses of each one. Okay, and we're going to use the atomic masses here. So for the Fe2O3, we're going to do 56 for the iron and times it by 2. And we're going to add on 16 for the oxygen times 3. So that's 160. Carbon is just 12, that's nice and easy. The iron is just 56. And then CO2, I'm going to do 12 for the carbon plus 16 times 2 for the 2 oxygens. So that's going to be 44. Okay, and then if you remember from the first example, what we now do is the mass divided by the relative formula mass, because that's going to give us the number of moles, which is what we need. So I'm going to divide each of these. So 480 divided by 160 is 3. 54 divided by 12 is 4.5. So we got 4.5 moles here. 336 divided by 56 is 6. And 198 divided by 44 is 4.5 again. Okay, so this is my ratio, but again, I've not got whole numbers. It'd be nice if we could get these into whole numbers to get the simplest ratio. So what we can do at this point is we can divide by the smallest again. Out of these, the smallest number is 3. So I'm going to divide them all by 3. Okay. So if we do 3 divided by 3 here, so that's going to be 1. 4.5 divided by 3 is going to be 1.5. 6 divided by 3 is 2. And 4.5 divided by 3 is 1.5 again. So this is a bit awkward because we've still not got whole numbers. We've got 1.5s. We could just go and put those numbers in. We can do 1.5s in an equation. But what we could do to get rid of the 0.5, well, 0.5 is a half, isn't it? So I could just times all these numbers by 2. So I think I'm going to do that because that's going to give me whole numbers every time. So if I just times by 2, times by 2, times by 2, times by 2, I'm going to get 2, 3, 4, and 3. Okay. And so that's how I've converted it all into whole numbers. Now you don't need to do that step. You could leave it here. You could actually have just left it with these numbers, to be honest. Okay, these are all the same ratio. They've just been multiplied by different things. But if you want to get it into nice whole numbers, then that's how you go about doing it. Divide by the smallest one. And then if you spot that you've got 0.5, times it by 2. And you might be able to spot other fractions. So for example, if this comes out as 1.333, you'd times it by 3. Yeah. If it comes out as 1.25, you'd times it by 4. Okay. But these then are my numbers that I'm going to then use to balance my equation. Okay, so we're going to have, let's see if I can get that in the screen as well. So we're going to have Fe2O3, but we're going to put a 2 in front of that. We're going to have 3 carbons. We're going to have 4 ions, and we're going to have 3 CO2s. And let's just check that that actually is a balanced equation. I've got 2 lots of 2, so I've got 4 ions here, and I've got 4 ions there, so that's good. 2 lots of 3, so I've got 6 oxygens here, and I've got 3 lots of 2, so I've got 6 oxygens there, and I've got 3 carbons, and I've got 3 carbons. So that is balanced.